In lesson 2.3, we're going to solve inequalities. I wonder if we'll be able to use some of the same strategies that we used for solving equations in the last lesson. Before we look at that, let's review what the symbols mean. If we're reading from left to right, like we normally do, then this symbol means greater than. Notice that the wide part of the symbol comes first, and the small part, the pointy part, comes second. If we flip that around, then reading from left to right, this symbol means less than. Let's look at a simple example to understand why the direction we're reading makes such a big difference. If I say that 6 is greater than 5, you're going to agree with me on that. And I read that from left to right. The big part of my symbol came first, and it was next to the big number. So I read 6 is greater than 5. But I could also read that from right to left. I could read it this way. But if I do, I'm going to say 5 is less than 6 to keep the statement true. I read that as a less than symbol, even though it's the same symbol. Since I was reading from right to left, the little part of the symbol came first, and that's why I read it as a less than. Let's look at another simple example. 2 is less than 3. The little part of the symbol is next to the smaller number, and when I read from left to right, the little part of the symbol came first. If I read that instead of left to right, from right to left, then I would say 3 is greater than 2. Now there's another symbol that you will see in this lesson, and it means does not equal. It's an equal sign with a line through it, and it just means does not equal. It can equal anything else except what that equation says. Now let's explore a little bit whether we can use the addition property that we used on solving equations for our inequalities. Let's stick with one of these easy examples. 6 is greater than 5. What if I add the same number to both sides? I'm going to add 2 to both sides, and I get 8 is greater than 7. Is that a true statement? It is a true statement. If I look at those numbers on a number line, then 8 is to the right of 7, which means that 8 is greater than 7. Now let's subtract the same number from both sides. I'm going to subtract 2. So 6 minus 2 is 4. 5 minus 2 is 3. Is 4 greater than 3? That is a true statement. So we started with a true statement, we subtracted the same number from both sides, and we still have a true statement. If we look at those numbers on the number line, then 6 is to the right of 5, which means that 6 is greater than 5. Now let's look at multiplication. What if I take that simple example and I multiply both sides by the same positive number? I'm tired of 2, so I'm going to multiply both sides by positive 3. 3 times 6 is 18. 5 times 3 is 15. Is 18 greater than 15? That's a true statement. On the number line, 18 is to the right of 15, which means that 18 is greater than 15. So far, it looks like the strategies that we use to solve equations are going to work for us on inequalities as well. Now let's take our simple inequality and let's multiply both sides by the same negative number. So I'm going to multiply by negative 3. Negative 3 times 6 is negative 18. 5 times negative 3 is negative 15. Is negative 18 greater than negative 15? If I put those on a number line, then negative 15 is to the right of negative 18. So that's the opposite of greater than. Negative 18 is to the left of negative 15, which means that negative 18 is less than negative 15. So when we multiplied both sides by a negative number, we had to reverse our symbol. That's a key note that we need to understand in this lesson. That's the most important idea in solving inequalities. You can do it just like solving equations, but if you multiply or divide by a negative number, you have to reverse the symbol. So pause the video and write that down. Now let's solve some inequalities that have variables in them. So in example 1, my variable is m, and I want to undo everything that's done to m, just like I did with equations. So I'm going to start by subtracting 10 from both sides. That zeroes out, so 5m is greater than 10. I'm going to divide both sides by 5. So m is greater than 2. Now when I divided by that positive number, I kept the symbol the way it was originally. I didn't change it. Now I want to be able to graph m is greater than 2. So on a number line, I'm going to put 2, and there's not an equal to on this inequality. So to show that I don't want equal to 2, I'm going to put an open circle here. If I do not have an equal sign on my inequality, I want an open circle. If the variable is on the left, then I want to shade all the numbers greater than 2. And the numbers greater than 2 are to the right of 2. Let's look at example 2. There's simplifying that I need to do on both sides of the inequality before I start getting the variable on one side by itself. So I'm going to distribute the 4 to both terms inside the group. And I'm just simplifying on each side. So 2 times x is 2x, and 2 times negative 2 is minus 4. Now I'm ready to get the variable on one side by itself. Just like with equations, there are different steps that you can take as your first step. I like to move my x's first, so I'm going to subtract 2x from both sides, which leaves me 2x minus 12 on the left and negative 4 on the right. Now I'm going to add 12 to both sides. That zeroes out the negative 12, and I have 2x is less than or equal to 8. Now divide by 2 on both sides, and x is less than or equal to 4. Now when I graph that inequality, I want to put the number, which is my boundary, I want to put the 4. And then this inequality has an equal sign on it. So that means I want a solid circle. You know you want your circle to be solid because of the equal sign on the inequality. Your inequality will either start with an equal sign or not. There's no way that you take the equal sign off or that you add it. There's no reason to take it away or to add it. So now we need to shade in the direction of the smaller numbers because x is less than or equal to 4. One thing that you can do if you're confused about which way to shade, if you just want to check, is to pick a number on one side or the other of 4 and substitute it into your answer. So if I picked 5, for instance, which is to the right of 4, and I put that in for x in my inequality, then I would have 5 is less than or equal to 4, and we know that that's false. That means I'm not going to shade on the right side of 4, I'm going to shade on the other side. If I had picked negative 10, which is a number to the left of 4, definitely in the shaded area, less than or equal to 4, then that would give me a true statement. So I know that I want to shade on that side. So it's really easy to pick a number and check if you're confused about which side to shade on. On example 3, the only thing that's happening to the h is that it's multiplied by a negative. I have negative, remember that could be negative 1h. So I want to divide both sides by negative 1. When I divide by a negative, I have to remember to turn that symbol around. It was greater than or equal to, now it's going to be less than or equal to. 7 divided by negative 1 is negative 7. If I graph that, then I plot my negative 7. I have an equal on my inequalities, so I want a solid circle, and then I want to shade to the left. Pause the video and work example 4. Check your solution. Remember, when you divide both sides by negative 6, you have to reverse the symbol right here. If we graph that, then we would put our boundary at 4/3, which is just 8 over 6 simplified. And we want to have an open circle, and we want to shade to the left because this is a less than. Example 5 is a does not equal problem, so we're going to start just like we would if that was an equal sign. Subtract 10 from both sides, and negative 20 does not equal 4x. When you divide both sides by 4, you get negative 5 does not equal x. If I graph that, then I want any number for x except negative 5. So I'm going to label negative 5, put an open circle to show that it is not included. But then I'm going to shade on both sides of it because x can be anything except negative 5. Pause the video again and work example 6 and example 7. Okay, I hope you paused the video. On number 6, check your work. Did you remember to reverse your symbol when you divided by the negative? On example 7, there were several ways that you could start this problem. I started by subtracting 6x from both sides. When I did that, I got a result of negative 9 is greater than x. Now that's reading it from left to right. Remember, if I turn that around, then x is less than negative 9. You don't have to write the variable on the left side, but sometimes it will make it easier for you to graph it. So when I graph it, I want to put negative 9 with an open circle, and I want to graph to the left. Now maybe you didn't subtract your 6x, maybe you subtracted 7x. Let's look at that work. So if I subtract 7x from both sides, then that's going to give me negative x minus 5 is greater than 4. And then I add 5 to both sides, and negative x is greater than 9. Now when I divide by a negative 1 to get x by itself, I get x is less than, have to turn the symbol around because I divided by a negative, negative 9. So I end up with the same answer, but different order of steps to get there. Take a couple of minutes to read through this problem, read it more than one time, and set up an inequality to describe what's going on, and then solve that inequality. Make sure you spend some time with it before you come back and check your answer. The question is how much money they made from selling the fidget spinners. I used the letter P for profit, but you can use any letter. Make sure you define it. So here's what I thought about the problem in words. Mr. B's profit minus the amount he spent on donuts has to be greater than the amount he took home. Now let's fill in what we know. We know that Mr. B's profit was 1/4 of the team profit. So P is the team's profit, and we divide that by 4. You can also multiply P times the fraction 1/4. Then we subtract the amount that he spent on donuts, which was $12, and that amount has to be greater than 3, the amount that he took home. Now solve that inequality for P. Here are the steps that I used to solve that inequality, and I got P is greater than 60. Remember, P is profit, so the team's profit was at least $60.